My dear students, on the continuation of the chapter Laws of Motion, we are going to discuss the concept friction today. Okay, so the chapter will be Laws of Motion, and today's concept will be that one friction. Okay, as you know, my name is Amarnath. So let us start our discussion. Okay, what is friction? You see, actually, say this one is a surface, okay, and say it may be a table, okay, or it may be a bed or something, anything, okay, and on it say one book is there, okay. So if I see the picture macroscopically, okay, though the surface seem to be smooth, but actually lot of humps and bumps are there, okay, on the surface, okay. Though we say that it is smooth, but macroscopically, if we see, we can find lot of humps and bumps. Na? So similarly, for the book also, you can say, if I draw the book here, that lot of humps and bumps on the surface. Okay, it is actually everywhere, but I am drawing only this part's irregularity. Okay, actually, no surface is so smooth. Okay, it is having lot of that one. Okay. So when the object, say this object is A, okay, it is placed over, yeah, on B, okay. So what will happen? Actually, interlocking arises now. So this is the A object and this is A of B object, okay. So as A falls on B, so there interlocks, okay, because of that bumps and bumps on the surface, no? It interlocks, okay. So that interlocking we need to understand actually, okay. This is actually main, we can say that it is the main cause of friction. Actually, we have lot of causes of that of friction, but it is the best way to understand, okay. So you see, if the object is just placed over B, na, so though it there the surface is rough, but friction will not take place. But friction will take place only when one surface has the tendency to slide over the other. Okay, friction takes place only at that time only. Okay, when when both are stationary, okay, sitting over each other, cool only. Okay, so there will be no friction. But if one surface has a tendency of moving, say someone is pulling it, okay, so then friction will be there. Okay, so let me discuss some situations. Okay, first try to understand the situation first. For our convenience, so we assume that this is the surface, it has say no friction. And let's say this is one object, it is say B, and B is also a book, okay? And let's say this is A, okay? Say A is also a book, okay? So if I pull B, okay? If I pull B slowly, okay? I see that A also comes with B, okay? It is a common action. You can also do this thing. Okay. Then remember, I have not applied a force on A. Na? I have not applied a force on A. Okay. So if you draw the free body diagram of A, so who is pulling A towards right? Because you see, if you apply a force on B, then also B moves, but A also moves with it. Okay. If you pull it slowly, then, but who is pulling A? I am not pulling. I am pulling B only, na? Because I have not any physical contact with A. But B has physical contact, na? So that particular force is called friction. So A is going right because A is stationary. Now it started moving towards right. So A's acceleration also will be right only. So it means the frictional force also will be right only. Okay. Symbol of frictional force is small f. Okay. So remember, that is very important. Don't think that friction opposes motion. Friction can create also motion. You see, as motion is created by friction only, not by my force. My force is capital F, but I have not created the motion of A. If the surface between A and B is smooth, no friction, then if I pull B, B will go alone. A will fall down only, okay? But if A and B has some roughness, some interlocking, then of course B will take A also along with it. Okay. So as A is going right, so A must get a force towards right. Okay, that is friction. Okay. So for A, friction is rightward. So who is giving this friction? B is giving. To whom it is giving? A. Okay. So this is the force on A by B. Okay. But if we draw the free body diagram of B, you see, if we draw the free body diagram of B, so for B, one force is already there, which is I have applied. But one frictional force will be acted on leftward. Okay. Why? Because we know that every action has an equal and opposite reaction. If B gives a rightward force, so in return, A will give B a leftward force. So this is called FBA, okay? The value of this and this will be definitely same, but direction will be just opposite, okay? So now you try to understand one thing. You see, try to understand one thing. This frictional force creating a motion, matlab causing a motion, okay? But this frictional force opposing a motion. Are you getting it? Means frictional force can create a motion also. Frictional force can oppose a motion also. Okay. Actually, what friction does? Actually, friction try to opposes the relative motion. Okay. If they are going together, then okay. Friction wants that only. Okay. But if one tries to slide over the other, means one's velocity is more, other's velocity is less. Okay. At that scenario, friction takes place actually. Okay. And friction tries to minimize that relative motion, means their velocity. If someone's velocity is more, friction will try to make it less. If someone's velocity is less, friction will try to make it more so that both velocity become equal. Okay. So friction always try to make their velocity same. That is the thing actually. Okay. If I apply a force on F, so B will have some velocity now. B will have some velocity now because I have applied a force. But A is having velocity 0 na initially. So friction will create that velocity so that A and B go together. Okay. Sometimes it can, but sometimes it fails also. Okay. We'll discuss when it will fail and when it will make the same velocity. Anyway. So first of all, what will be the definition of friction? You see, definition of friction is I have already written the definition in my, I think, first or second class, but I'll go in depth, okay, today. So what is friction? It is the force appeared between two surfaces in contact. But remember, that definition is not completed. You have to write when they try to move on each other, or you can say when they are when they have the tendency of relative motion, when they have the tendency of relative motion. Okay, the definition is completed now. Okay, this is the friction definition. Remember,
Sir, but you have already told this before.
pardon?
Sir, you have already told this before.
That definition I have already told you. Yes, yes, yes. Friction is always parallel to the surfaces in contact. Okay, you can write that point also. You can write that point also.
So what is after force?
Huh?
What is like written after force?
Value of frictional force.
No, no, like it is force, like what is after that?
Okay, after that. Appeared. Appeared. Okay.
Got
Appeared.
it, sir.
Frictional force is always parallel to the surfaces in contact. Okay. Normal force is always perpendicular, but frictional force is always either it will be forward or it will be backward like that. Frictional force is always parallel to the surfaces in contact. Normal force is always perpendicular, but frictional force is always parallel. Okay. Then friction can cause a motion. Cause a motion. Means friction can create motion. Okay. I have already given the example. It can oppose a motion. It can, remember, not it must. Okay. It can oppose a motion. But it always opposes relative motion. Okay, relative motion. But it always opposes relative motion. Say in space, you imagine, say this is one, say this is International Space Center, okay? And it is going with, say, uniform velocity v. And say one object is lying over it, say one astronaut, okay? It is also going with v. So there is no requirement of any friction because both are going with the same velocity, okay? No requirement of any friction. If friction arises, it will be accelerated. So it means there is no any friction. They are going together smoothly. But if one started moving with higher velocity, say 2v, so it means that this object will try to reduce its velocity. So it means friction will be acted this way. So as every action is an equal and opposite reaction, so friction will be acted this way. So for this object, friction will be rightward. For this small object, friction will be leftward. If it increases velocity, okay, like this. Means always try to cause of that change in velocity, you can say, okay. If they are going together, both the surfaces are going together, so there will be no requirement of friction, okay. Please draw the figure also, huh? So whatever I have told you, please draw the figure also, okay? Because then only you'll be comfortable, okay? Now we are going to calculate the value of frictional force. Huh? That is very important. We need to calculate. Huh? Okay. See. Okay. Okay. Let me know once you complete writing. Okay.
Yes, sir. Completed, sir.
Okay. Think of your that one. Okay. Say on the floor. Say this is the refrigerator. Okay. Say a big object. Big object. Okay. So as it is heavy, so obviously the interlocking will be more, na? Interlocking will be more. So you imagine, say I am applying a small force, say 3 Newton. Will the fridge move? Will the fridge move? What do you think? If I apply a very small force, 3 Newton, will the fridge as a whole move? I think no. So
No, sir.
as it
It will
as
not.
it will not move. So as it is not as it will not move. So what does it mean? Net force on it must be zero, no? So it means when I apply 3 Newton force, so the frictional force also automatically will be 3 Newton only. Okay. So it will not move. So net force must be zero. If only 3 Newton is there, because you see this is mg, it is already balanced by normal reaction. Okay. In vertical direction, we don't have any problem. In horizontal direction, I have applied 3 Newton. So if the fridge is not moving, it means friction also must be 3 Newton only. Okay. But if I apply 4 Newton, then also say I can increase the force. Na? If I apply the 4 Newton, then also say fridge is not just moving. Okay. Not sliding. It means what? Friction is again 4 Newton. So it means friction can adjust itself. Okay, that is a very important point. Friction is a self-adjusting force. Very important. Okay, so that way, if you keep on increasing, when you apply 10 Newton, it will give 10 Newton. When you apply 20 Newton, it will give 20 Newton. Friction. It will adjust itself. Okay, but one time it will fail. Na? If your papa also come and mother, your mommy also come to pull the freeze. So assume, say when they apply 200 Newton, assume, when they apply 200 Newton together, then it starts moving. So it means frictional force cannot move, cannot go beyond 200. Are you getting my point? So frictional force is, see, it is an example only, I am giving. Frictional force is adjusting itself from 0, 1, 2, 3, up to 200 Newton. When you start giving 200 Newton, then it starts dragging. So if you apply 300, then obviously it will not go. It cannot increase the frictional force. It will apply only 200 only. Okay. That is the maximum limit that can be given by the interlocking. It means you can say that now the interlocking is broken. You can say, okay, interlocking is removed. You can say now they will slide over each other. So if you apply 500, then also it will give 300 only. Okay. That is why you write a point. That is why you write a point. Friction is a self-adjusting self-adjusting force which changes from 0 to a from 0 to a maximum value from 0 to a maximum value. Here in my example, maximum value is what? 200. Okay. To a maximum value, and which is called limiting friction. Limiting friction. Remember, this is also definition of limiting friction. Okay. Somebody can ask you, what is limiting friction? You can say that the maximum value of friction is called limiting friction. And limiting friction symbol is F max. F suffix max. Okay.
Excuse me, sir.
Okay. Tell me.
Sir, is like there any formula to calculate
Yes, yes,
how
yes,
the
yes. Yes,
can
I'll
apply
give.
maximum?
I'll give. I'll give. Wait. Okay. I'll discuss all the things. Okay.
Okay, sir.
This is applied force. You can give anything, but frictional force cannot be anything. Okay. Frictional force always has some upper limit. You are pulling it. When your mummy joins, the force will be more. When your papa comes, then again force will be more. You can use another that one also, na bulldozer also to pull some very heavy object. Okay, but frictional force means your applied force can be infinity depending upon that. But frictional force, after certain time, they break their interlocking. Okay, they start dragging over each other. Okay, so that maximum frictional force is called F max. Main cause of friction is the main cause of friction is what? That is roughness between the surface. Okay, roughness between the two surfaces. So if the roughness, if the surfaces are smooth, then frictional force will be what? Less or more? If the surfaces are smooth, then frictional force will be
Less.
less. We can easily drag it. Na? But remember, if I give one example now, there is a smooth surface only, but very, very large frictional force acts there. Remember, this sentence is not completed. Huh? The last sentence, I have to add something more. You think of a glass slab. Say this is a glass slab, okay? So normally glass slab is a smooth surface, no?
So,
Yes or
what
no?
is the meaning of slab?
Slab means that one. Slab. Piece of glass, okay?
Got it, sir.
So this is a glass slab. Say your work is going on in your that one home, okay? Windows windows frame are that constructed by the carpenter, and one glass should be that one, okay, given in the window, okay? So like that, say two glass slabs are there lying over each other, okay? So this glass slab is lying over another glass slab. Remember, it is very risky, huh? You don't do it. You don't do this experiment, but it is fact. So if two glass slabs are lying over each other, if you cannot even pull, you cannot drag a glass slab over the other, okay? Though they are very smooth, but their frictional force will be very tremendous. Very tremendous means much that one bigger than the that one rough surfaces frictions, okay? So Now that one main cause of friction is roughness. If the main cause of friction is roughness only, then of course it is wrong, na? Here actually it should be some another cause also there, na? So what is that cause actually? Let me know. Actually, what happens? The main cause of friction is not only the roughness, also, but also interatomic forces between the molecules in contact. Okay, say this is the upper glass slab. Okay, and say this is the lower glass slab. Okay, then actually that molecule and this molecule make some actually bond. Okay, bond actually. This molecule also, this molecule makes some electrostatic bond. Okay, so that is why actually if somebody asks you what is the nature of frictional force, you can say that it is electromagnetic. It means because of this type of forces, na, one particle gives the another particle, that is called electromagnetic force actually. Okay, so that is also a cause. Okay, so how can I conclude the statement? Main cause of friction is roughness between the two surfaces and the intermolecular or interatomic. Okay, interatomic. Atomic means this atom and this atom, this atom and this atom, this atom and this atom. I don't know whether it is atom or molecule. Okay, so it may be interatomic or it may be intermolecular. Okay, intermolecular, interatomic, or interatomic or intermolecular forces. Okay. How to reduce the friction using oils, greasing, or you can give powder also. In carom board, actually you see, say this is the carom board, okay, carom board. And this is the coin, okay. So what you do, you just sputtered some powder, na? So powder particles are very spherical, na? So then actually friction becomes less, okay? Because rolling friction is comparatively less than the sliding friction, okay? So this is the powder particle, okay? It is like a sphere, na? It is like that on wheel of a car, na? So this is the carom board striker. It is going this way over the carom board, okay? So this is the carom board striker, okay? So if you don't spray some powder, so it becomes sticky. Do you love playing carom board? Okay. So you can experience this thing, okay? So how can you reduce friction? Friction can be reduced by lubricants, using that on oils, lubricant and oil almost same only, using powders like this, okay? Now we come to the mathematical part, okay? So what is the mathematical part? Actually, basically, we are going to discuss how to calculate the maximum frictional force, okay? F max. How to calculate the maximum frictional force. Can I go to the next page?
Yes, sir.
You please write down law of friction. From this law, we can calculate anything left?
Yes, sir. Yes, sir.
Law of friction. See, think of this thing, one thing. Say this is an object, okay? You imagine when you apply a 10 Newton force, then say the object starts dragging, okay? But if you push this box, okay, from some outside, then the requirement of force to drag the object will be more or less. What do you feel? Say one box is there, I can draw it using say 10 Newton force. But if one baby comes and sit on the box, now for me it will be difficult or it will become easy only to drag the box. What do you say? What do you think?
So I guess it will be difficult.
It will be difficult because you see when the baby sits on the box, so they are interlocking, interlocking between the surfaces will be more tightly bonded. Okay, tight. Are you getting my point? So it means what? Actually, when someone is pushing downward, it means their weight is going on increasing. Okay, so you can say that the frictional force value actually depends upon the that normal reaction provided by surface, because normal reaction and mg they are proportional. Normal reaction will be more when mg is more. So what is law of friction? Law of friction says that the maximum frictional force means limiting friction. The limiting friction that is F max between two surfaces in contact is directly proportional. Directly proportional means if one increases, other also increases. Directly proportional to the normal reaction. You know how to calculate normal reaction. Already you have done, normal reaction between the two surfaces. So you can write that F max is directly proportional to N. And you draw the Fibonacci diagram also here. Say I have applied a applied force, but here actually it is frictional force. Here it is mg, which is downward. And here it is normal action, which is upward. Okay. If you somehow increase the N, then F max also will be increasing. Okay. Then F max, as I have already told you, so when the proportional sign is converted to a equal sign, okay, if you just write here equal, then actually one constant is required. Okay, that is a rule actually. That constant is mu here, mu. Symbol is mu, mu. This is called something mu. Okay. So that is the main formula. Okay. So what is mu here? Here mu is a proportionality constant.